Hey guys, in this video we're going to talk about independent and dependent events. So we learned that the probability statement looks something like this. Probability, P, which stands for probability, favorable, whatever we desire, and then equals number of favorable outcomes over the total outcomes. So let's look at an example here. And this is going to be independent. So let me write that to the side. Independent. And I'll explain why it's independent in a second, but let's see this here. We have a die here and we have an event A rolling on a 1 on the first die. So in every 6-sided die, we have 6 numbers, 1 through 6. So and then we have 1, 1 on a fair-sided die. We have 1, 1. So let's write a probability statement for this. So we have P. What's favorable? What is the question asking us? Rolling a 1 on the first die. So probability of rolling a 1. The first die just means this die right here. So rolling a die or rolling a 1 equals, and we can have only 1, like because we only have 1, 1. So frequency is 1. And how many total outcomes are there? Well, I can roll a 1, I can roll a 2, 3, 4, 5, or 6. So there are 6 total outcomes. So probability of rolling a 1 is 1 out of 6. Now dependent, not dependent, next event, which is event B, it's still independent. So rolling a 3 on the second die. Well, this is independent because rolling a 1 here on this die will not affect the outcome of this die. So probability statement, rolling a 3 equals, well, we only have 1 3 on a fair-sided die, and then we have 6 total outcomes, 1, 2, 3, 4, 5, 6. So you can see that they're the same, the probability of rolling a 1 and probability of rolling a 3. So these are independent events. So whatever happens in event A is not going to affect event B. Now let's look at this one right here, and I'm going to give you a hint. This is a dependent event. Dependent events right here. So event A is actually independent. And event B is dependent. So for dependent events, what we're going to do is first focus on the independent, drawing an odd number, which is independent event A. So drawing an odd number out of these 10 cards, well, we have 1, 2, 3, 4, 5. 5 out of 10 are odd numbers. So we're going to write 5 probability of odd, because that's our probability statement, favorable, equals number favorable. We have 5, right? So 1, 2, 3, 4, 5. So 5 over total of 10 cards. We can simplify this to 1 over 2. But I'm going to leave it as 5 over 10. And you'll see why. So event B says drawing the number 7 after an odd number has already been drawn. So what we notice here is that this after an odd number has already been drawn, that is event A. So therefore, if you have part of the previous event in your next event, that means it's dependent. So drawing the number 7 after an odd number has already been drawn. Actually, I'm going to make this number 8. So drawing the number 8 after an odd number has already been drawn. So let's say I pick the number 5. So 5 has been drawn out. So we are going to remove this card, put it aside. Okay, so now that I have these cards, what is the probability of drawing an 8? So probability, or just P, drawing 8. And then we only have 1 8, so 1 over, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total cards. So you see how we had 10 here, 10 total outcomes, but now we have 9 because we're not counting the 5. We took the 5 out of the bag or out of, the table. This is what dependent and independent events are. So just be cognizant about that. So independent events, the previous event does not